Welcome back to the AK App Logic channel. Today we are going to discuss about the number system topic part 3 video, which is the final part of the related to the concept. From afterwards, we can able to discuss about the problems, and during problems, I will discuss some of the most important points which are related to the questions and shortcuts too. So this is the last part for the concept video. After I will gonna make a problems series in this playlist only. The playlist will be given in the description. Let's dive into the video. This is a short video which has only some 2 to 3 topics. That's it. See, the first we discuss we're gonna discuss about the factorial of a number, modulus of a number, greatest integral value, and multiplication shortcut methods and division algorithm or Euclidean algorithm. Important facts, some other important facts. So let's dive into the video. So first, the factorial of a number. The factorial of a number is nothing but let be the n be the number positive integer, then continued product of its n natural numbers. Continued product of its n natural numbers will be called as factorial of n. Okay, the factorial of n is denoted by n and exclamatory mark. Okay, like this we will denote the factorial of a number. Okay, the factorial number will be equal to the, this is the general form of the factorial of a number. N factorial is equal to n into n minus 1 into n minus 2 and so on up to 1, not 0. If you do a multiplication with 0, it will become 0, right? So up to 1 only. Okay, so for example, 5 factorial will be 5 into uh, 5 minus 1 as per the general form. Okay, as per the general form, 5 factorial will be 5 into 5 minus 1, 5 into 5 minus 2, okay, into minus 5 minus 2, and so on up to 5 into 5 minus 4. Okay, and so 5 minus 4 and into 5 minus 3, right? Before there will be 5 minus 3, right? So if you are going to say this, then you will get the resultant as 5 into 4 into 3 into 2 into 1. Okay, that is only here given, right? So if you multiply all these values, you will get the 120. And remember that the thing, 0 factorial is always 1. This is the important point you should remember. 0 factorial is always equal to the 1. This is the star, means it is very important point. Okay, remember this point while solving problems. You may confuse. Okay, so the next topic is the modulus of a number. The modulus of a number is, modulus is denoted like this. If a number is given x, then if you the modulus of x means you will denote like this. It is also called as mod x or modulus of x. Okay, so mod x will be minus, it's also it's plus. Okay, for mod x will be x for x less than 0. If the value x is less than 0, then modulus of x will be x. If the value of x is greater than or equal to 0, then modulus will be x. It is minus only. Okay, remember it is minus only, not less. Okay, yeah, then if you, here is the example, the modulus of minus 5 will be 5. Okay, the negative number will become positive. Okay, when we place it in modulus. Okay, the positive number, it remains as positive only. It not going to convert into negative. The positive number remains into the positive only. Only the negative number will get converted into the positive number. That is the thing, means the modulus. Okay, next, yeah, the greatest integral value. The greatest integral value of an integer x is denoted as x with the square brackets surrounding by. Okay, is given as the greatest integer not exceeding x. So it means if the given number is x, then greatest integral of a value of x will denoted as like this, the square brackets in between we have the x. Okay, so if you given a question like this, 2.49 uh, equal to question mark, if your question is given like this, what is the answer? If your question is given like this, by saying these braces, you square brackets, you can able to understand that they are asking the integral value of this particular value 2.49. The integral value of 2.49 will be 2, so it means we will neglect the point value and we will take only integral part, which means integer part. Integral part means integral integer part. The answer will be 2. So let us see an example. See for example 1.35. So there is square brackets around it, right? So we for from that we can able to know that they are asking the greatest integral value of the 1.35. Then the resultant will be 1. We will exclude the 0.35. Okay, then resultant will be 1. So here the another question is 11 by 4. What is the integral value? It is in the fraction, right? 11 by 4, it is in the fraction. So first we have to divide, make into the decimal point. Okay, 4 2s are will be 8, the remainder will be 3. So we put the point, and if you add the 0, 4 7s are will be 28, and the remainder will be 2. If you put the 0, then 4 5s are will be 20. So it means we get 2.75 as a resultant. You can see here. Yeah. So we will neglect the decimal part, and the remaining integral part is 2. So then the value integral part of the value 11 by 4 will be given as 11 by 4 will be given as 2, right? So whenever you have given with the fraction, you have to convert it into the decimal point, then you will get to know what is the integral value. Okay, the next thing, yeah, let me erase multiplication shortcut methods. Okay, multiplication by distributive law. Okay, distributive law has two formulas. One is a into b plus c will become like a into b plus a into c. This is one type of formula where a b c are the numbers. Okay, yeah, a into b minus c will becomes a into b minus a into c. So it's get multiplied like this one, and there is in between minus is there, no, that minus will be like that only. Okay, similarly in the first case also, first it will get multiplied like this, and second it will get multiplied like this. In between what the symbol is there, the positive is there, right? Plus symbol is there, right? So the plus symbol itself will be there. Okay, so the next let's say an example. This is an example. We're going to multiply two numbers, right? One is 567,958, other is 5 nines. So you have to think very logical way. Here is the 5 nines, right? So you have to mention like this: one 5 zeros minus one. Okay, one 5 zeros minus one. It is in the form of multiplication, right? Doing two 5 digit number multiplication is somewhat difficult, right? So we are going to write like this. Now the second formula will be applicable to it, right? Because there is minus between this, so it will be a. Let me change my pen. Okay, see, it will be a, right? It will be a. It will be b. It will be c. Then what happens? A into b, right? A into b minus a into c, right? So we will multiply this, then the resultant will be this. It means it is AB. After multiplication, it is AB, and minus in between there is minus, right? See, in between there is minus, right? So the minus will be asterisk, and the next is AC. Okay. So rather than multiplying two five-digit number given here. Okay, so it is better to do this subtraction, right? I think once, yeah. So that formula make uh, this particular formula, the second formula makes us feel easy, right? Makes us feel easy to solve the particular multiplication, right? So in this way, this formula is useful. Let us see another example. Let me erase this. Yeah, if you want to see another example, they are given 978 into 184, 978 into 816. So it is in the form of this, right? Yeah. Rather than multiplying three uh, three digit multiplication two times and add them, it is better to multiply once, right? Yeah. So we have to think very wisely. Here the one of the number is common, right? What the number is common? 978 is common, right? 978 common. What are the other two numbers? So 184 and 816. So when you can say that this is as A, okay? This as A, right? So we have to decide what is B and whether you need to perform addition or subtraction. You perform both the addition and subtraction to other two numbers. Those are 816 and 184. Okay. 816. First of all, we will go to subtraction. Okay. So the result will be 2. Okay. It will be 11. It will be 11 and it will be 3. Okay. It will be 7. Okay. 7 minus 1 will be 6. Okay. So the resultant is 632. It means if you perform taking common, sorry, here there is plus, right? So you must make the plus, right? So make the plus. Okay. If I'm saying in the case of where plus or minus, I'm mistaken. Okay. You perform addition 184. Okay. You will get the resultant as 1000. Okay. You will get the resultant as 1000 after doing this. Okay. So we have using this formula. Okay. So it means when you have taken the common 987 using this formula, then it will be in the form of this, where the 987 will be A and 184 will be B and 816 will be C. Okay. Now if you add both the values, you will get the 1000. You simply multiply with 978. It means we will add the three zeros after 978, right? So it makes our problem very easy. Rather than uh, uh, doing the three digit multiplication two times, one time and two time, after again three addition, okay, we simply add one time and we multiply with 1000. It's not a big deal, right? So it makes us feel very very easy. Okay. So this you also remember these two formulas when solving the big number recurrence. So when you are going to see in the exam, if the examiner give you 10 minutes, if there is 10 minutes for each question, you can able to solve without any shortcut. Okay. But in examination you will get only 30 seconds. Okay. In 30 seconds of time you will feel very tense by seeing these five digit numbers, two five digit numbers that multiplication. So you will feel very tension and worried. So without tension and all this, if you want to write the exam, you must remember these formulas and you must identify. Not only remembering these formulas, you must identify what is A, what is B, what is C, and you must identify which formula is suitable this particular for some which formula is suitable for some other some. Yeah, we have to identify. Okay. Yeah. Next, multiplication shortcut methods. Whenever you multiplication number by 5 power n, okay, this is also a very good shortcut. put n zeros to the right of the multiplicand, and multiplicand is nothing but when you have the two numbers a and b, so a and b are called as multiplicands, okay? A and B and call as multiplicants. Any one of them we can able to say it as both the numbers we can able to say that multiplicand. Okay, when you are going to multiply with 5 power n, okay, then we have to divide the we have to uh, append n zeros, append n zeros to the right of the multiplicated. For the other number will be there, right? So for that number we have to add zeros and divide the number by formed by the 2 power 4, 2 power n. Okay, so we can able to say that I gonna explain this with an example. Okay, so here given a number, big number, 5-digit number and a 3-digit number. If you see this number, particular number 625, it is in the form of 5 power 4, right? 5 power 4. So it's the meaning that where n equal to 4, right? So this is the thing. This shortcut is useful when it is when a given number is multiplied with the 5 power 4. Okay. So there is 4, right? You add 4 zeros to the right side of the other number or the multiplicand. The other number is this, right? So we will add 4 zeros. Why we are going to add 4 zeros? Because the 625 we can able to represent in the 5 power 4, right? It means power in the power there is 4, right? So we have to add 4 zeros to the other number or the other multiplicand. So there are 4, we have added the 4, okay, numbers. So then you have to divide. See, you have to divide by 2 power n, where n is 4 in this case, right? If you're gonna do this 2 power 4, you will get the resultant as 16. Okay, so if you are gonna remember the 16 divisibility rule in the previous class, if the last four digits are zero, either zero, or if the last four digits either divisible by 16, then we can able to say that the given number is divisible by 16, right? So here the last four digits we make it them as zeros. How? By adding four zeros and we have just divided by 16, right? It's a shortcut. Okay, so now dividing this number is easy with 16 because we already known that it will be completely divisible by 16. The number which is there over here, which is changed into the this number by adding four zeros, we can able to know that it is easily can able to divisible by 16. So you just do the normal division, then you will get the answer in very easy way. Okay, so this is also one shortcut. Next, division algorithm or Euclidean algorithm. Division algorithm or Euclidean algorithm is nothing but you are having the 5. Okay, if you are going to divide 5 by 2, so this will be called as dividend. Okay, this will be called as dividend. Okay, dividend. Okay, the number which we are going to divide is called as dividend. Okay, the number which we are going to use as a divide, which we are gonna use to divide a number is called as divisor. Okay, this is called as divisor. Okay, divisor. Okay, so if you're gonna divide, let me erase this. Okay, no, let me continue. 5. If you're gonna divide with 2, then you will get the remainder as 1. How? 2 twos are 4. So 2 twos are 4. The particular 2 is called as quotient. Quotient. Okay, quotient. 5 is called as dividend. 2 is called as divisor. and this particular 2 which is over here is called as quotient, and we gonna write 4, right? 4. 5 minus 4 will be 1. Okay, the particular 1 which we got over here is called as remainder, because it is being remaining, right? Because after we dividing with the 2 4 2 times, and we will get the remainder, means it's been left. Okay, so we call it as remainder, remaining, remaining, right? The one is remaining, right? So we call it as remainder. So now if you are going to multiply divisor into quotient, you will plus remainder, you will get the dividend, right? 2 into 2, 4, 4 plus 1, 5. So this is the division algorithm rule, or Euclidean algorithm. You can see this. Yeah, if I divide given number by another number, here we are what we have done, 5 divided by 2, right? In our case we have done with 5 divided by 2. Okay, then dividend equal to divisor into quotient plus remainder. What we have yet, quotient as 2 and remainder as 1, right? So if you're gonna see this equation satisfying or not, 5 equal to divisor, what is divisor? 2 into, you have to mention the brackets. Okay, this brackets 2 into quotient is 2, right? And then remainder is 1, right? So according to Bodmer's rule, you must simplify the braces, uh, the value which is in the parenthesis. So in the parenthesis we have the 2 into 2. It means the resultant will be 4 and plus 1 will be equal to 5. So the 5 is equal to 5, right? So this is the rule of the Euclidean or some Euclidean algorithm or division algorithm. Okay, yeah. Next, some of the important facts let us come to know. Okay, yeah. Where is the eraser? Yeah, let me erase this. So if you're gonna see this, these are, if x power n minus a power n is divisible by x, x power n minus a power n is divisible by x minus a. In the sense, if you're gonna take x as 9 and n as 1, 9 power 1 minus a as 4. Okay, 4, and it has power is 1, right? So if you find this resultant, you will get it as 5. Okay, so what is meant by x minus a? That is 9 minus 4, right? So 9 minus 4 is also 5, right? If you divide the value which is x power 1 minus 4 power 1 by the x minus a, then you will get, uh, it is divisible by for all values of n, right? Yeah, so both are getting divisible, right? So if you change it as 2, okay, 2, okay, 9 square, okay, 9 square will be 81, 81, 81 minus 16, 81 minus 16, how much it was? Okay, 5, and here will be 6, isn't it? Yeah, if you're gonna add 65 plus uh, 16, you will get obviously 81. We get this, right? We're gonna divide this by 9 minus 4, that is 5. You will get the resultant as 13. Okay, it means for all values of n, this condition is true. So this condition is true, right? So this is a one of the formula. Why you are going to discuss all this means, in some of the examples they will give like this. So whether this is divisible or not, they will ask like that. So we have to remember all this stuff. Okay, the next thing is x power n minus a power n is divisible by x plus a for all even values of n. So if you are going to take 9 again 5. Okay, 9 power, we will take first odd. Okay, odd means we are going to take 1. 9 power 1 is odd, that is 1, right? Minus, you have to do, right? 9 minus 5 will be 5. Okay, so 9 plus 5 will be how much? Because it is divisible by x plus a, right? 9 plus 5 will be 14. It means 5 by 14. 14 can't able to divide the 5, right? Is it correct or not? 14 can't able to divide 5. So here we already mentioned, right? For all even values of n, it means 1 is not the even value, it is the odd value. So for odd, this condition is false. It means for only even value, it particular thing will work. It particular x power n minus a power n is divisible by x plus a for only even values of n. So let us see with 2, when n equal to 2. Okay, so we have taken 9 power 2 and minus 5 power 2. Okay, divided by is 9 plus 5, right? 9 plus 5, what is the formula? 9 plus 5, what is this? 14, right? We 81 minus 25, 81 minus 25. Sorry, previously I have done a mistake, right? Yeah, in that case I have taken 16, right? So 81 minus 25. In the previously I have taken 16. I forgot it. Oh, sorry. That's the other case, right? Previously I have taken 4, right? Okay. Yeah. 81 minus 25. 6, sir, and 9, sir. Okay. Is it correct or not? So sorry, this is the 5, right? This is the 5. Means the value is 15, 56. 56 minus 14. How many times? 14 4 are 56, right? 14 4 are, we will get the answer as 56. It means the n is 2. Here the n is 2. So it's an even value. For even value, the condition is always true. This particular condition. Okay. So let us see the last condition, which is this. Yeah. X power n plus a power n is always divisible by x plus a. Let us take the thing. So 9 power 1. Okay. Here we are going to take the n as odd. That is 1. Okay. 9 power 1 plus 5 power 1. Okay. 9 power 1 plus 5 power 1 is always divisible by 9 plus 1, 9 plus 5. You not only 9 plus 9 and 5, you can take any number. Okay. You can able to take any number. So the resultant will be 14. Okay, here also the resultant will be 14. So 14 can able to divide 14 by one time. So this condition is true for the odd value. Similarly, you guys check for the even, putting the n value as even 9 square plus 5 square. So 9 plus 5, we already seen that 14. So whether this is divisible or not, it is definitely not divisible because here the n value is 2, right? So let us see. 81 plus 25 is equal to the 106. Is it right or wrong? Let you guys check. Okay. So is 106 divisible by 14? Is 106 divisible by 14 or not? If you guys do this, 14 sevens are 98. So the remainder will be 8. It means we are getting the remainder, means remainder other than 0 means it is not divisible by, completely not divisible by the number. So this condition is only true for the odd cases. This condition is only true for even cases, whereas the condition which is and above this is only way for the all the n values. Okay, let us see some other point. This is the thing. To find the highest power of a prime number p in 50 factorial, highest prime number power in 50 factorial, highest power of p, where p power r less than or equal to n less than or equal to r plus 1. So to discuss this, it will take a long time. So just remember, just write it down in your notes. I will discuss this thing very properly when it is used while solving problems in the coming videos. Okay, just write it down. Okay, I will explain this. Okay, yeah, thank you guys. Like, share, and subscribe to AK at Logics. So the thing is, now the conceptual videos have been completed. Now I'm gonna follow the RS Agrawal Exchange Publications book, Quantitative Aptitude book, right? So in that, I don't want to solve all the problems. I will solve the problems which are most of the people are facing the difficulty. Okay, so this type of problems I will solve, and remaining problems you guys solve it, uh, and I will discuss most of the important points. There are so many important points. Now, this is the basic information concept that you guys must know while solving the problems. And there is also some other important points. I will discuss those in the coming videos. Okay, while solving the problems. And thank you guys. This is it. It's very short video. It's only half an hour video. Thank you.